Hello students, let us continue with the next part in molecular spectroscopy, and we are still discussing regarding rotational spectrum. In today's class we are going to discuss regarding isotopic effect. So before going to study regarding isotopic effect, let us know what is an isotope. So isotopes are going to be the elements which have same atomic number but different mass number. For example, if I just want to consider the nuclei of carbon 12 and carbon 13, what do we observe is they have got same number of protons but the number of neutrons is going to be different. In case of carbon 12 nuclei, the number of neutrons is going to be 6 and the atomic mass is going to be 12. But in carbon 13 isotope, protons are going to be 6, neutrons are going to be 7 and atomic mass is going to be 13. So elements which are going to have same atomic number but different mass number are called as isotopes. And due to the extra neutron, this isotope is going to be heavy in nature. Isotopes have same chemical properties but different physical properties. So in isotopic effect, let us know we know that isotopes have same chemical properties but different physical properties. There is no appreciable change in internuclear distance on isotope substitution, but total change in mass is observed. There is no appreciable change in internuclear distance on isotope substitution, but a total change in mass is observed. Moment of inertia changes which ultimately results in decrease in B value, as moment of inertia depends on the atomic mass. So what do we observe is, as moment of inertia changes, ultimately what happens is there is going to be a decrease in B. Considering the carbon monoxide, we know there are two isotopes of carbon, that is carbon 12 and carbon 13. If in one carbon monoxide, that is in carbon monoxide 12 is replaced by carbon 13 in carbon monoxide, the mass of 13 carbon monoxide is going to increase. And as the mass is going to increase, what do we observe is there is going to be a decrease in the rotational constant. That is, in carbon monoxide with isotope 12, the rotational constant is going to be 1.9211 centimeter inverse. But when this carbon 12 is replaced by carbon 13 isotope, what happens is the rotational constant is going to decrease to 1.83669 centimeter inverse. So there is going to be a change in atomic weight as well. What do we observe in due to the isotopic effect is the spectrum of heavier species, that is carbon 13 is going to be a heavier species. The spectrum of the heavier species will show a smaller separation. It is going to show a smaller separation. When we are going to compare to this isotope carbon 12 isotope, carbon 13 isotope in carbon monoxide will show a smaller separation between the lines of 2B than the lighter one. This is going to be 2B dash. This is going to be the 2B dash, but whereas this is going to be a lighter one, that is 2B. So what do we observe is due to the substitution of isotopes, and the heavier species will show a smaller separation between the lines in 2B dash than the lighter one in 2B. We can see the effect of isotopic substitution in case of rotational spectrum. Here this is going to be for the heavier one. This is when I go on to consider chloride, which is where the atomic mass is going to be 37. I go on to get the peak over here. That is, the difference is gone. And in case of the lighter one, the separation is going to be more. In case of lighter one, the separation is more. Whereas in case of heavier one, the separation is going to be less. So what do we observe is, from the spectra, we can obtain bond length or atomic weights. Using the isotopic effect or the effect of isotopic substitution, from the spectra, we can obtain the bond length or atomic weights and atomic abundances as well. The spectrum can be successfully used to calculate. The atomic weights of isotopes. The study gives directly an estimate of abundance of isotopes by comparison with the absorption of intensity. So, in today's class, we had studied the isotopic effect on rotational spectra. Thank you.